Hey everyone, Randal Schwartz here, back again with another Dart and Flutter tip, trick, or technique. Today we're going to talk about the best practices around Dart exceptions. So here's a quick rundown of what we're going to be covering in this talk. The fact that there are three categories of exceptions and what they are. Some general syntax about try, catch, finally. I'm not going to try to teach the whole thing here, just to remind you of all the parts. Then we'll talk about some guidelines for catching these exceptions, guidelines for throwing them, and even rethrowing them. And then mention a bit about how to enable lints to get us to do the proper thing most of the time. And then we'll have some guidance about further information and where to go for that. So I want to talk about the three broad categories of exceptions. First, there's literally exception and its subclasses, many of those. And that means that something happened that should interrupt somehow the normal call return flow that happens when you're calling functions and subroutines and methods. So it means something unusual happened, although reasonably predictable that it might happen. The second broad category is error and its subclasses. Error is reserved for when something the programmer did is mistaken. There's a case that isn't being taken care of, or an array is out of bounds, or just something really unrecoverable has happened, in the sense that the programmer needs to do something to avoid that situation again. It has to be fixed before shipping this to some end user. And because of this, it also means it should never be caught, even in production, except to activate some sort of phone home mechanism. So your mobile phone can log an error message to your analytics to say, something really catastrophic happened. The final category, which might surprise some people, is that everything else except null can also be thrown. So I could, for example, throw the number 7 or the word hello. Typically don't use these. We don't use these because they're much harder to predict if we're looking at code that this is really about some sort of exception. So I use them rarely, mostly for a debugging interrupt. I want to know if the code got to a particular point, and when it got there, you might as well throw the object of interest as well. That way it's already displayed for you. Now, just as a little bit of a refresher, let's look at a typical try-catch block and what it looks like in the code. We have try and a block of code. That block is being run with exceptions being handled, caught. The try block can either return a value, which means it's returned from the parent function that this is in, or in this case, it's executing in a void context, and we'll simply throw away the result. Then we have a series of on-catch calls. If anything of IO exception or its subclasses, it'll end up doing that first one, with the error going into E and the stack trace going into S. Most people don't catch the stack trace, and I'll explain why over the next few minutes, why this is very important to actually hold on to. So IO exception would be the base class that would be caught by that. So E will be some subclass of IO exception. Further down, we just have on any exception, so that includes IO exception. This also indicates that the order matters. If exception had been before IO exception, we would have never gotten to the IO exception specifics. So the order is the order that they're checked. Further down, we have error, and notice there's no catch clause. If there's no catch clause, then the error and the stack trace are just ignored. They're kept around internally for rethrowing, but that's the only place they're actually accessible. So there's error. The next one is catch ES, which is catching everything. It's catching exceptions, it's catching errors, it's also catching if I throw the number 7. So this is actually disrecommended at this point. because you don't want to catch anything that's not an exception. We'll see this over and over again through the rest of the talk. And then finally is a block that will run regardless of whether the try block went to its successful point or if there was a catch block that was triggered by an exception. Either way, the finally block is run. And then if we're still in the middle of throwing something, that will then get thrown. So that's going to be the orientation of that. So here's just a few guidelines for how to deal with catching those exceptions. First off, very important, don't catch what you won't handle. I see so many catch blocks set up that then immediately rethrow it because they're not ready to deal with it. Just catch the things you're interested in. And once you catch it, you've got a few options. You can log it and rethrow it. You can repackage it, put it inside some other object, and throw that object. Or you can replace it with a substitute value, as if the error never happened. Also very important to keep in mind is don't catch any non-exceptions, because exceptions are really the only thing that you should be throwing if there should be some recovery at a higher level. So errors, for example, should yell at the coder, say, hey, fix this. It should be fixed before we send this to QA or ship this to customers particularly. And again, don't throw random object classes, okay? So really, exceptions are the only things you are intentionally throwing and or intentionally catching. So what are some of the guidelines for throwing errors? You should throw an error subclass to inform the programmer that they've made a mistake. And for example, there's an assertion error, which is clearly a subclass of the error class. And that's used by the assert operation during debug and profile times, but not production times, to say that some assertion has failed. Therefore, the program is not operating in a way that was expected. And you generally won't need to invent your own error subclass because the built-in error subclasses, I think there's about a dozen of them, are fairly broad. For example, unsupported error. You can put any message you want there. Argument error is one of those that has named constructors as well. So, for example, an argument error not null is particularly towards identifying an argument that needs to not be null. So what about throwing exceptions then? That's probably what you'll do more of. So again, you want to throw not exception itself, but a subclass of exception. And that means that you would typically set up a hierarchy of subclasses with a base class with all the additionally local useful information fields for everything that are children of that class. And the base class should either extend or implement exception itself. And the point of that is that the linting messages will properly pick up that you're throwing something that's not an exception. This is simply hand-waving saying, look, I'm not implementing anything from exception, but I am implementing the exception interface, which means, yes, it's a legitimate thing to throw for exceptions. Don't let these exceptions leak from your library. Typically, a library needs to return non-exception values at its borders. If you do decide to add an exception return value as a potential return from your library, be sure it gets documented. Be sure all possible exceptions get documented so that when I'm consuming your library, I know what code I need to write. Here's a quick example of putting that into practice. We implement exception in our client exception class. We're going to ensure that every client exception contains a client as a required parameter. We're also going to have subclasses that represent a particular kind of client exception. Client quota exceeded exception, client not authorized exception. And note that these don't have any additional payload other than the client. And that's all we need to count on as we're parsing through those and figuring that out. But then we have client not available, where we have a string message that is optional, but would provide maybe additional information about what might be actually happening. Also, just for grins, there's the definition of client. Of course, we'd really want that to include equatable and a toString that works and things like that. But this is just for purpose of illustration. But this is an example of a hierarchy of exceptions that you could then throw and reliably catch. For example, client exception would catch every subclass of those. Or you could have a pattern match that scans through and figures out which one of those you're talking about. Let's revisit the log and rethrow point that was made earlier. This is useful when, for example, you want a trace of what had happened, but still expect the caller to handle it. So you want to know on the way out something happened, but you really expect somebody else to take care of it. Very important when you're doing this to log the stack trace. It's very frustrating to know that some exception was thrown, but have no idea where it actually came from. So in this try and catch, notice that we're trying some operation. We're catching it. We always include both the exception and the stack trace in the log message so that we have some sense of where it came from. And then we use the built-in rethrow to basically say, now act like this catch block wasn't here. Go ahead and let it ripple upward in the exception handling technology there. So another strategy is repackage and rethrow. And for example, what that would mean is you can build your own exception that in turn contains a caught exception, the exception in the stack trace from the original message. For example, I may want to take all the DO exceptions that could happen from using the DO library and repackage that as a client exception, being one of my classes. So I would create the intersection of client DO exception, and yes, it is a client exception, so it will have a client in it, but we'll also include the error that has come from our stack trace, our error that has come from our catch, and our stack trace that has come from the catch as well. And so the try block for that would include on DO exception, we're going to catch both E and S, error and stack, and we're going to construct a client DO exception and rethrow that. Notice that it has the client information from somewhere and the original error and stack. And we know that the error is a subclass of DO exception, and that's part of the handshake protocol there. We can refine repackaging slightly for potentially cleaner stack traces. Instead of just throw client DO exception, you can use the static method error throw with stack trace. You pass your newly created exception object as the first argument, and the original stack trace from S that you caught as the second argument. This technique often does a better job of associating the point of failure in the stack trace with your custom exception, making it clearer where the underlying problem originated while still presenting it as your domain-specific exception type. Here we wrap any caught exception into a client any exception using this method. The third main handling strategy is replace with substitute value. This is useful when a failure isn't critical and you can provide a sensible default or fallback to allow the program to continue. Notice in the example, the try block attempts to return the result of an operation if it succeeds. If it fails with an appropriate exception, then we log the error, but then return a null as its replacement value. Dart has excellent static analysis, and you should definitely leverage it. Use the lints. Packages like Very Good Analysis provide curated sets of lint rules that enforce many of these best practices automatically. I highly recommend using it or a similar strict set. Some key lints related to exceptions include: avoid catching errors. That prevents you from catching error types. Avoid catches without on clauses. This pushes you to be specific about what you want to catch. Only throw errors. Ensures that you only throw error or exception subclasses. Empty catches. Flags when you catch blocks, it flags when your catch blocks have nothing in them, potentially hiding errors. Use rethrow when possible. Again, reminds you to rethrow to preserve the stack traces. And others like control flow and finally and throw in finally help avoid confusing and potentially problematic code in finally blocks. Unawaited futures can help catch potential asynchronous errors that might otherwise go unnoticed. Seriously, enable these lints. They will catch many common mistakes. We've covered the core concepts today, but there's definitely more depth to explore in Dart error handling. We didn't dive into alternative patterns like using result or either types from packages like fpdart or multiple result, or Flutter's async value to represent success-failure states, especially instead of throwing exceptions. We only briefly mentioned top-level error catching for crash reporting, which is like phoning home. There's more nuance to handling errors with futures and async operations using methods like catch error, on error, and when complete. The best practices for writing helpful two-string methods for your custom exception hierarchies. More specific strategies for dealing with errors within Flutter widgets. And the role of zones, very important, in Dart's asynchronous error handling. There are lots of interesting topics. Maybe we'll cover these in part 2. Finally, if you're looking for more great Dart and Flutter content, here's a few YouTube channels I highly recommend. Of course, there's mine, Randal, on Dart and Flutter. You should definitely subscribe to the official Flutter channel at FlutterDev. And of course, the Flutter Community channel at Flutter Community aggregates fantastic content from many different creators in the ecosystem. Check them out. And that wraps up our look at Dart exception best practices. I hope this gives you a solid foundation for handling errors more effectively in your Dart applications. Thanks for watching. Be sure to like this post and subscribe to the channel, and tell your friends.